Hi everyone! In this video I'm gonna introduce Rovi and we're gonna talk about the design, the hardware and the software. Rovi has a modular design. This means that it can adapt to a variety of tasks, including lawn moving, which can be done by this big module which moves the lawn, or you can have an extended battery, or use cameras like GoPro, navigation using ultrasonic sensors for distance measurement, and speakers and many more. So, how does it work? Well, you remove the cover and then just slide whatever module you want, and then you obviously have to connect to the module, but we're not gonna do that now. There are also many adapters. You go from these big ones to these small ones, which can hold small things like this ultrasonic sensor or another cameras or other things. There are also adapters on top which can hold, for example, this camera with servos, can move along the X and Y axis, or the antenna for GPS signal and outdoor navigations, like that. And then you just remove it. Yeah, it's simple as that. Okay, now let's go to the hardware. In the hardware section I want to talk about battery, motor, gearbox, tracks and the chipset. So let's start by the battery. I use a lithium-ion battery which consists of 6 cells. This battery chemistry is used in many applications, including electric vehicles and electric bikes, laptops and many more. It has a capacity of 100 watts. This battery also has a power indicator, so when you press the red button it shows the percentage of power left. Now it's showing 50%, around 50%. Then there's the BMS. It keeps the battery healthy and happy. You can think of it as a battery doctor. This is the motor I use in a Rovi. It's a brushless DC motor, which means that it runs on a direct current and it needs a special controller that mimics the use of brushes in a normal brushed motor. It has higher efficiency than brushed motors or normal motors, therefore it is used in performance or high efficiency scenarios like drones, RC cars and many more. This specific motor has 120 watts of maximum power, but only 15 watts are used during normal operation, and it has the maximum speed or RPM at 9000 RPM. Next on the list is gearbox, or more specifically planetary gearbox. This same type of gearbox is used in cars with automatic transmission. It is great for high speed and high torque applications, for example like in a car or right here in a Rovi. Okay, so why do we use gearboxes? We use gearboxes to reduce the speed because otherwise it would be ridiculously fast, and to increase the torque, which increases the force by which we are turning the gear and the tracks. If you want to check out more info about these gearboxes and the difference between planetary and spur or normal gearboxes, and the difference between the ratios of these gearboxes, you can click on the link to that video in the description of this video. And now the tracks. I decided to use tracks because they are simpler than wheels and they have better energy transfer to ground than wheels. And it is much simpler than wheels, meaning that you don't have to use any differential or steering mechanism, you just have two independent sides. If you want to check out more info about these tracks or comparison between these off-road ones and these normal ones, you can click the link to that video in the description of this video. And finally, the chipset or microcontroller. I use the ESP32, it's basically something like a Arduino, and it has two cores and which run at 240 MHz. It has Wi-Fi and Bluetooth with integrated antenna. You can see it, it's right here, the antenna. But I also want to upgrade to a single board computer, something like a Raspberry Pi, which uses Linux and basically is a normal computer, and this could be beneficial for AI stuff and ML stuff, which include object detection, object recognition, and path following, and like stuff with cameras and so on. And this is how the insides of Rovi look like. You can see the motors right in there with gearboxes, and here the blue stuff are the controllers that run and control those motors. Here is the ESP32. Here are some voltage regulators and capacitors. A switch. This switch is used for changing operational modes, or you can program it to whatever stuff you want. There is also this big red switch that is used for turning on and off the Rovi. You just physically disconnect the battery from the entire system. This is another useful feature or component, and that's the speedometer. It's a photoelectric sensor that consists of one transmitter and one receiver. The transmitter transmits infrared light into the receiver, and if the receiver or the path gets blocked by one of these blocks on the wheel, it gets picked up and it sends the signal to the ESP32 or other microcontroller. And by this I can calculate the speed of turning of the wheel. And now let's go see the software. For the phone application I use a framework called Flutter. It's easy to use, fast, and most importantly, you can deploy apps on Android, iPhone, Windows, Macs and Linux from one single code which is written in Dart. Here you can see how the app looks. It has a very simple and practical UI. I admit it doesn't look so good, but it does get the job done. You control Rovi by either the sliders at each side or by specific buttons like forward. There is also this settings/additional cool features zone in which you can set the operation mode, lights brightness, Morse code, acceleration and so on. You can also use a controller like Xbox controller or PS5 controller to control it, but you still need to go through the phone. For the microcontroller, I use Arduino IDE with ESP32 setup. It's easy to use and has great documentation. And that's pretty much everything I wanted to say in this introduction. I hope you enjoyed this video, and don't forget to check out those videos about tracks and gearboxes. There are some cool comparisons and explanations of how it works. Thanks for watching, bye bye!